Hello, everybody. A warm welcome from Berlin, as usual. Today, we're going to talk about the AIOps portfolio again. This is another instance of our video series, AIOps Explained. So today, we're going to talk about custom fields. But before we do that, Zane, do you want to say hello?
Hi, Fred. Yeah, Zane here, speaking from London.
This is the agenda of today. We're going to briefly introduce the Cloud Pack for AIOps as it is. Then we want to talk about how we do the event schemas in the Netcool portfolio, mostly Netcool Operations Insight, but it's absolutely the same if you're still on OMNIbus and Impact, because these base components are the same. So we're talking about object servers, and in that database, that memory resident database, we do have a table which is, let's say, status. That's where the fields reside, and that's where those are defined and used for the event containment. Then we're going to briefly hit gateways because they are resyncing these object servers as well as they are exporting data away from the object servers, and we're briefly touching the probes. All these three things go together as soon as you touch these fields. It's a little bit different in the new Cloud Pack for AIOps. That's touching the object server connector, and that's where Zane is going to talk about, and we're having the demo. That's for the agenda. Last but not least, we're going to talk about documentation, where to start for this exact topic. So this will be one of the shorter videos, I hope. The IT automation portfolio as such, this is an overview slide. You can read it, I think, best from left to right. So we do start with proof points. So you want to monitor your environment. You want to see what's out there in terms of networking and in terms of servers. So what kind of hardware do you have? How is it connected? So this is something that you do have with element managers. Our application performance management suite is preferably using Instana as one of our most recent acquisitions. So we do APM with Instana, discovering, deploying agents, learning what a data center looks like, or many data centers, what's installed in there, how is it performing, and it's a really good source for us to learn from an AIOps perspective. We do also have components which touch network environments, so we can discover networks, we can do configuration management, we do performance management, for example, with Ceph1, one more of those acquisitions. Then we go into application resource management. That's where we are combining this monitoring data with financial data. So we are giving it a price tag, and we're watching the applications and the performance for applications, and we're seeking for optimizations. That's where Turbonomic comes into place. It looks for exactly these kind of optimizations and puts them into reality. So first way of doing that is suggesting these kind of optimizations. For example, exchanging one storage for another, which may have a different performance, but it's cheaper, but it's still good enough for a specific expectation of the application because it's not so heavily burdened at the moment. So you could save quite a lot of money. Those exchanges are also qualified, so you can get a good overview of, is this change going to be reversible? Is it going to be something that can be done online, so you don't need to restart your infrastructure? As soon as you have all these information at hand, you could do it yourself, or you could let Turbonomic do the trick for you. And there's also the part Aptio in it. So this is going more into FinOps type of operations. This is where you go into financial analytics and where you combine these kind of capability of optimizing the infrastructure from a financial perspective together with the FinOps suggestions. This makes it a very nicely solution, these two in combination, but they also provide a nice part of the picture in terms of topology as well as changes. So these are things that we want to keep track on. And that's exactly where then the Cloud Pack kicks in. The Cloud Pack takes all that data, performance data, topology information, change data. We also talk about logs and ticketing. We put it all together, set it in context around an application or a network service or whatever you're selling as a service. We try to give all this context some meaningful interaction. We try to bring it together into a single pane of glass. That's exactly where the operator is then looking at. So we try to reduce the noise as much as possible and also provide the means to rectify problems. That's where we go into the take action part of the solution. Runbooks, for example, could resolve your issues. We could use Ansible scripts or any other kind of means in this kind of environment to make the life of an operator easier, to get him less work to worry about. That's what the Cloud Pak for AIOps does. Speaking of architecturing, most of our existing today's clients do have a Netcool history, and as such, they do have a virtualized environment of these Netcool deployments. That's what you can see here on the lower part of this slide. At the upper part of this slide, you see the additional components that do come with the Cloud Pak for AIOps. So usually you would install that into an OpenShift environment and then connect these two together. And because the object server itself has a data format, which is stored in the object server itself, in the alerts.status, this is where those fields do reside. And let's dive a little bit deeper into these object servers, gateways, and probes. So I've taken the liberty to dive a little bit into my PowerPoint history, and then I found these old slides which really depict what it was at those time. So you do have the fat client here. There's a little snippet here on top of that. This is about the object server, and with this client you could define and look into the object server capabilities. So you would see here the object server databases itself. You're capable of putting new tables in place as well as new fields on the fly. And you do have a couple of restrictions in here. So whatever you do within that kind of object server, you are bound to a max row size. And the maximum row size is all fields together cannot exceed 64 kilobytes of size. There is also a limitation. For example, the maximum field size itself cannot exceed 8K. And of course, there's a third restriction. The maximum number of columns, so number of fields, is 512. These three restrictions is what the object server has to live with. That's typically very fine because most of our existing customers never ever had a problem. But over time, object servers do get integrated into more and more things. And with each and every of those integrations, you add extra fields. And as we do evolve our object servers over time, we as IBM have also ideas about new fields which need to be in the object server because we hook some kind of extra functionality in there. And so over time, these limitations set quite some boundaries which were fixed. You can't overcome them. There's no way to get out of that. But here's a good story part, because the Cloud Pak now has a different technology. So we're not using object servers per se. So we do not have these boundaries anymore. And we could introduce new structures on the fly. And Zane is going to talk about these new structures and how and where to introduce them and what to. Probes do provide event data, and touching through this slide animation here, this is how it is. So you do have this raw data coming in. You have the rules file, which is mapping the raw data into the common event format of the object server. And the last part is to talk to the object server and deliver the event. But when the probe starts, it initially talks to the object server and learns what kind of possibilities do we have in the alerts.status table. So what is the current layout of the object server? And only after that initial read, you then have the knowledge within the probe what kind of fields it can promote. And if you change these object server fields, then you need to restart the probe as well. That's one of those things that you need to consider when you are playing with the object server map. Gateways are also something to consider, because gateways do also read the object server layout on start. And in the gateway, you also do have a mapping that needs to be synchronized. So for example, if it's the bidirectional gateway, which is synchronizing two object servers in a resilient setup, then the mapping needs to be reflecting what the layout of the object server is, or those fields will not be mapped over by synchronization procedures. And that's what I have for preparation. I hand over to Zane now. Let's talk about the new stuff. The new stuff is going to happen in the object server connector, and as such, there's a definition file. Zane, all yours.
Thanks, Fred. Hi, everyone. So as Fred was saying, the object server has certain limitations in the maximum size of a field, the maximum number of fields that a row can have, and the maximum overall size of a row as well in a table. What we're going to see shortly when we look at the AIOps event store is how the new Postgres-based event store changes the way the event data is stored and how those limitations are effectively removed. So what we're going to walk through is we're going to walk through a scenario where we have events in an object server. We've got a couple of custom columns, and we want to reflect those columns in AIOps. First of all, we want to display them in our GUI, and then finally we want to create an AIOps policy that will filter on those custom fields, do a thing. In this case, it will be mapping events or runbook. So we'll step through all of those steps so you can see how it works. And in the process, we'll actually sort of see the new event schema in AIOps as well. So what you can see on my screen here is my trusty native event list with the events coming from a SIMnet probe. And I've got a couple of custom fields on the right-hand side. We've got app ID and region. So these are custom fields I've added to my object server. And in my probe rules file, I'm just pushing a placeholder value. So my app and global are the values that I'm putting in those two columns. Let's start with step one. This is the GUI for AIOps, and what we're going to do is look at the integrations tab. Just to speed things up, I've pre-opened these tabs. So in integrations, we've got a number of integrations here in my demo environment. One of them is the IBM Netcool Operations Insight Object Server. So this is basically the Netcool Connector, which we use to connect to an object server pair. So in here, I've got one connector that I've already set up. And if I go into the configuration, we'll take a look at a few things that you do when you set this up. So the first thing that you do is you have to run a bit of SQL in your object server to prepare it for use with the connector. So as you can see here, you add a couple of columns, AIOps alert ID and AIOps state. The latter of those two basically constantly reflects the state of the alert in AIOps back into the object server, so you can actually see the state of the alert in AIOps from your object server view, which is handy. The second thing it does is it creates a trigger group and creates a trigger. And basically the trigger is handling the updates to the event when we clear or close the event in AIOps. If you haven't already got the scope ID field, it asks you to add that too. And then finally, a command for how to import the SQL into the object server using NCR-SQL. So now you've prepared your object server for use. The next step is to define the connection parameters in terms of the username password if you want to apply any filter. So this filter means that you don't necessarily want to bring all of the events over to AIOps. This is where you can put a filter in to specify which events. So for example, I might say here, I only want to bring SIMnet events over. So I might say alert group equals SIMnet, for example, or something like that. So I can put a filter in there if I want to. But then the primary and backup object server details, the host name, IP address, etc., and then the port. Under the covers in the Netcool connector is a message bus gateway. It forms one of the components of the Netcool connector. And it uses the message bus gateway to reach out to the object server and connect to it. It connects initially on the port that you specify here, and then it makes a second connection, of course, to the IDUC port, however it's set up on your object server. So if you've used a fixed IDUC port or an ephemeral one, it will make two connections to your object server. So something you need to bear in mind is if there's a firewall between AIOps and the target object server, make sure those ports are open. Otherwise, the connector will not be able to connect to that object server. The final step in setting up the connector is to define the mapping. Out of the box, it has a whole load of default stuff, and it's pulling various default columns from the object server, or replicating those over, as you would expect. Now, in our case, we have added 2 custom fields. So you can add custom fields either to the resource attribute. As you can see here, the resource attribute has all these sub-attributes: name, location, IP address, etc. And it's mapping to things like node alias, location, node, and other fields. So you can add them under here, or you can add them to the details section. So in my demo setup, I have opted to add my custom fields to the details section. And you can see here, this is using this JSON-ATA format. So app ID, it says here, if you read it across, app ID is going to be mapped to alert. So it's like a little logic statement here. If alert.appid is null, then it's this particular attribute's undefined. Otherwise, set it to the value of that. Same for region. So this is a notation that you'll see throughout this mapping. Basically, if it's a null value, then it won't have one in AIOps. If it is otherwise, if it does have value, then it will use it. This is as simple as it is. You just basically add all of your custom columns either under resource or under the details section, as you can see here. So now that I've done that, it will take a few moments for that particular container to spin up and connect to the object server and initialize. And then what you will see is alerts coming through into your event list. So you can see here, I've got a whole load of SIMnet probe events coming through from all these different sources. And if I double click one, we will actually get an insight into how the event is stored in AIOps. I've double clicked here and I've got a little pop-up on the right-hand side. It's got a familiar tabular display showing all the main default fields. But if I click on the raw tab here, you can actually see the actual full copy of the event, the JSON that stores this event. And you can actually see all of the various additional attributes which aren't shown in the tabular view. At the top, you can see the details, and you can see my 2 columns that I've mapped, and you can see the values coming through, my app and global. So if you recall, these values are coming from the original events. What I can deduce from here is the mapping is working and the values are coming through. So that's great. Okay, so now that I'm happy that those details are coming through, the next thing I'm probably going to want to do is to add them to my view. If I scroll all the way to the right, you can see I've got a field called region in my view and a field called app ID in my view. Unsurprisingly, all the events that are coming from the SIMnet probe have got these 2 fields populated, global and app ID respectively. So how did that happen? Well, it happened because I edited my view. I'll go into that now. And I added those 2 columns down the bottom, as you can see here, details.region and details.appid. And for each one, I specified, just like you would in Netcool, how you want the column header title to look in the view, the alignment of the header, the alignment of the data, and the width. So this is all pretty much exactly the same as you would be used to in Netcool when you're editing views. It's just the same more or less. So if that's saved, then the fields are now visible and available. And just like in the object server, if an event doesn't have that field populated, it will just come up as blank, just like it does in AIOps. Okay, now you can see here in the Runbooks column, all my SIMnet events have a runbook associated with them. So how did I do that? So this is the last sort of part of the demo today, is linking an AIOps policy condition to a custom field. Jump over to here. You can see here I've got my custom policies here, the ones that I have defined. And one of them I've called test 12. So if I edit that one, I can take you through. So this is a policy that it will fire when an alert is created, and it will associate the alert to a runbook. If I scroll down, you can see how the condition set is formed to filter on events coming from my SIMnet probe. In this case, instead of saying the alert group is SIMnet probe, I've done it specifically to use my custom columns, my custom attributes, because I wanted to show you how you would do it. So what I've done here is I've typed in the box here, detail, and I've selected the one that it offered me, value of alert.detail. Because alert.details has got sub-attributes, it's automatically offered me this little secondary box here, as you can see here, details name. So that's why that's popped up. It's optional because it's a sub-attribute. So I've typed in the box app ID. I could have used region, right, or any of my custom columns that I have under the details subheading. And I put here alert.details app ID equal to the string my app. And then underneath, I've assigned it to this particular runbook here, just for example. But this is basically, hopefully, will give you a sense of how you can use your custom attribute in condition set. And it's the same for any policy. So this is a policy that maps events to a runbook, but the condition set looks the same in any kind of policy. The end result here is, as you saw before, the events are now getting mapped to the runbook. So, in summary, what have we done today? We have looked at events originating in OMNIbus, mapping through a Netcool connector, which we set up, configuring the object server, then configuring the mapping to include our custom columns. And then what we've done is, in AIOps, we've configured our view to also include those custom columns, and we've created a runbook to map to those custom column field values and assign a runbook to that. So, how does that sound, Fred? Does that all make sense to you?
Very good.
Yeah.
I have a question for you.
Sure.
So in the old Netcool times, well, let's call it Netcool times, the old Netcool times, we always paid attention to performance. So when we made these kind of filter statements, wherever we did, we had a ranking, and the first ranking was integer equations. For example, for your filter on SIMNet probe, I would rather prefer a class equals 3300 than a string comparison. How do we need to pay attention today in the Postgres environment? Does it really matter anymore, or do we have to consider performance? What's the best practice here?
Well, in the old Netcool world, what we would do is we would specify our filters in WebGUI. We would use sort of a graphical representation, but we also had the option to actually type in the SQL. And you're quite right, when it's executed against the object server, there would be sort of a goal to try and arrange your SQL so that the cheaper operations are attempted first. So you would put your integer comparisons first and your string comparisons second, particularly if they're regex expressions. In AIOps, when you define a filter, as you can see here, there is sort of not that same scenario really. It's basically, you can see all these default ones where you just check boxes and you add additional conditions. And there isn't really that focus on ordering of anything anymore like there used to be. So in this case, not empty. So you basically add them here, but as you can see, there's no way to sort of control the ordering at all. You would just basically put them in. And as you can see here in this example, I've used my custom column app ID, and it's worked. It's an interesting question to ponder, but it's not one we can actually control in the same way that we used to. The presumption, therefore, is that it doesn't matter too much.
Yeah, or we haven't investigated it too far.
Possibly.
This is new technology.
Yeah, there might be more information to come on that, and there might be more controls that are available. But the way it is today, there isn't. You just add your conditions as you need.
Especially when you're in high load environments where you have gazillions of standing events, may or may not impact performance.
Right.
Cool. I love it. So this eliminates quite a number of problems. So I do have a number of customers who did have a row size limit, really had this kind of problem. And having this kind of capability of just defining it, and additionally you just define those structures and can use them immediately, and you do not have to restart the components.
Yeah,
so
that's a great point, Fred, and it's something you mentioned right at the start, is in the new Postgres schema, because things are stored as a JSON payload, you don't have to declare them first. You don't have to say the type is or anything. You just use it. And there's no programmatic limit to either the number of attributes you add or use. And there's also no programmatic limit to the number of rows that you can have in the system at any one time. Now, there is some work that's being done to dramatically ramp up the performance of the alerts list and all the various other processes that access the event store. But the idea is that eventually Postgres, it's envisaged, will become the centralized store for all events from all of your object servers. So that is the holy grail, because then we can actually, look at all of our events in one place and then do event analytics across all of my events. So this is particularly of interest to customers that have more than one object server pair in operation, and it tends to be the larger customers that have too many events for one object server alone. So yeah, It's exciting.
Yeah, and
It's
I
exciting stuff.
remember the early times of the Cloud Pack. I had one of those demo setups, and I played with the SIMnet probe, and I played with deduplication and the identifier. And I left the system in the evening as is, up and running. And the next morning, without any further considerations, I came back and I saw I had well over 600,000 rows accumulated, and the event list still opened as if it would have been nothing. So there's quite a difference between the new AIOps capabilities as well as the existing object server capabilities. So I'm really excited about this new technology and what we're going to see in the near future. So really cool stuff. I like it.
Yeah.
So we don't want to hide that we have documented these kind of things. So if you are going into the documentation and want to read about that, you need to go into the connector part. Here's a link which takes you to event mapping and alert severity. So here's a documentation part of how this Cloud Pack to Netcool mapping works out of the box and where to make these kind of mapping changes. So this is here. And we do have also the community in place. So if you want to talk to us or post something or exchange with other customers, this community is a great place to use. So we are blogging here quite regularly, Zane, me, and our colleagues. And there is also training and certification available. We do have face-to-face classes here in the upper right place. There's an installation class as well as an administration class. And in the training curriculum, there are also a few online classes free of charge available, which are around that topic of administration and installing the Cloud Pack itself. And if you really are in it and want to show your skills, then you could go for the certification. That's a Prometrics test center-based certification that we have available. It is at the moment on the version 3.2 available, but I think we're going to renew that to version 4 at least quite soon, but we haven't decided yet. So at the moment, it's a version 3.2 certification available. But honestly speaking, from an installation and administration perspective, it's not that different as such. So you still install to an OpenShift environment. You do have to do the same things to set it up, as you could see in more videos and more videos. That's on the next slide. So we do have these videos all stored in YouTube. There's an IBM channel. It's the IBM Helps account. And in there, we do have the IBM Support TV. And as such, we do have quite a number of those videos already recorded. I think the last count was 44, and we do have at the moment a total view count of 105,000 total views. So thank you for watching all those videos and talking to us about the content. If you do want to see something else, just let me know. And Zane and me, we're here to make these kind of videos available for you, even on short notice, because it's not that much effort. So with that, I'd like to thank you. Thanks for watching this video and for spending your time. And thank you, Zane, for the cool demo. And see you another time.
Thanks, Fred. Bye, everyone.